there are 698 instances in our data of clump thickness. That is the reason why count is 698. Mean of that clump thickness is 4.41. This is about central tendency. In the descriptive statistics, central tendency is giving about mean, median, mode, min, max. Okay na? Dispersion. Dispersion is not in dispersion. We will talk about range, quartile, IQR, variance, standard deviation. As you can see, standard deviation here. IQR in the sense IQR score, that is we will get that by using Q3 minus Q1, which is 25th 75th percentile minus 25th percentile. We will get here we are also having median. Okay na? I think you are getting my points. This is about a statistical analysis, in which specifically it is about here we are talking about descriptive statistical analysis. Okay na? Inferential statistical analysis takes the data from the samples and make inferences about the larger population from which samples has been drawn. Which means, see guys, so here descriptive statistics is only telling about what exactly data we are having, what is the mean of that, what is the median of that, what is the mean of that, what is maximum of that. So it is giving an overview about the data. Descriptive statistics is saying that, but whereas inferential statistics is giving us some predictions, inferences in the sense predictions. So if data is like this, what if a patient's and woman's data, if that is new instance, how it is behaving by training with this old data. So that is giving inferential statistics is giving us new inferences. It is making some predictions by we are taking small amount of data, we are training with that, and we are predicting it for larger population. That is nothing but inferential statistics. In this descriptive statistics, there is one other type of descriptive statistics. So whatever you see, data set dot describe, there are in the descriptive statistics we will be having central tendency. In central tendency, mean, median, mode, min, max. Dispersion, that is quartile, IQR, variance, standard deviation, skewness. This is about these are specifically known as standard descriptive statistics. They are known as standard descriptive statistics. Other descriptive analysis you can perform, such as accessing the relationship between pair of data. So by seeing data set, if you find min, if you find max, if you find count, this is known as standard descriptive statistics. There is one more descriptive statistics, which is finding the relationship between two columns. As you can see, relationship between two columns can be found using two techniques. One is covariance, second one is correlation. First one is covariance, second one is correlation. As you can see here, clump thickness, this is a function that is available in Python to find the covariance. I will tell you the difference between covariance and correlation also. Wait for a while. So first you can see here there is uniformity of cells. Here it is representing the relationship between the clump thickness and uniformity of cells. This is the relationship between here we are seeing the relationship between two columns. This is also one type of descriptive statistics, finding the relationship between two columns. Okay na? Finding the relationship between two columns. Correlation is doing that, covariance is also doing that. So what is the difference between covariance and correlation? You might be heard in our physics in 10th standard or 11th standard about scalar quantity and vector quantity. scalar quantity and vector quantity. What exactly scalar quantity is representing? Scalar quantity will tells us only the direction, but only the magnitude, but not direction. Okay, now it is showing the sign but not direction. Vector quantity representing both magnitude and direction. So you think of like this: covariance is just like a scalar quantity, correlation is, it is vector quantity. Here what is magnitude, here what is direction. Let us see that. So here what is here you can see now. Now I am talking about covariance. Let us see here, guys. So uniformity of cell size and clump thickness, what is the relationship? Here the relationship is 5 point something, right? So here it is saying that there is relationship between these two, but it is not saying whether it is improving that or depriving. Let us see. For example, what our main intention? Our main intention is to identify whether whether a woman is getting stage class 2 or class 4, that is malignant or Belgian. We need to finally we need to predict that. So let us see the relationship between these two. So see, uniformity of cell size. Let us see relationship between this uniformity of size and class. So the relationship between these two is 2.37. So here we are having magnitude. Magnitude in the sense there is some dependency between these two rows, between these two columns, but we don't know whether that is increasing or decreasing. So whether the uniformity of cells is uh, is giving us correct output or not. Here we are only knowing there is 2.37. It is only showing some magnitude, but it is not showing direction, in the sense that it is not whether it is predicting correctly or not. We don't know that. Here we don't know whether it is predicting correctly or not, whether this uniformity of cell is a attribute that is exactly predicting whether a woman is having stage 2 or stage 1 cancer or stage 2 cancer. That is not telling that. It is only, it is giving, yes, there is two dependency, there is some dependency between class and uniformity of cells, but it is not showing whether it is not telling us whether it is predicting correctly or not. It is not showing the direction, it is only showing the magnitude. Covariance. Let us move on to correlation. Okay, now let us move on to correlation. Okay, now so correlation is see, let us see here correlation between uniformity of cell, clump thickness and class. Okay, now clump thickness and class, uniformity of cell size, uniformity of cell shape, and let us see between, we will compare with classes, because our aim is to predict whether a woman finally has stage 1 cancer or stage 2 cancer. Okay, now here forget about this. Let us move some theory concept about correlation. Correlation is exactly about is of three types. One is positive correlation, second one is zero correlation, third one is negative correlation. If one value is increasing, if other value also increases, then we say that that is positive correlation. If one value, here value in the sense column, if clump thickness increases, class increases, so we will get positive correlation. If when we get zero correlation, if one value increases, other value may increases, may not increases, and may increases or it may decreases. In such scenario we will get zero correlation. When we get negative correlation, when one value increases, other value automatically decreases. If both increases, positive correlation. If one increases, one decreases, that is negative correlation. If one increases, one may increase nor may decrease. So in that case we will get zero correlation.